Welcome to problem 6. So we work with the group Neal 2.2. Have to show it's isomorphic to the symmetric group of 3 elements of order 6. And then the map of the Galois group of K2 for 4 groups that I didn't put on here, so I have to write them by hand. But let's start with the general linear group 2.2. I have 2 viewpoints. The first is to take it as matrices in their own right, and when the determinant is non-vanishing, we can't have naught both as a row, either as a row or a column. So there must be at least 2 units. So that's the unit matrix and the exchange. And then we have we can't have 4 units. That's determinant vanishes. So we can have 3 units. They can be at 4 places. So that gives us the rest of the 4 matrices. So we can have naught anywhere we want. So to identify, there are only 2 groups of order 6, so it can be either either S3 or the cyclic group of order 6. We can actually let them work on a vector A point B, and then see what happens. Or should we take the order of each element? So we have the unit and our B here, and then just choose C here. C squared equals 1 times 1 times naught, that's unity. You know what, I'll just write it and do it very slowly. One, that's naught. 1, naught. Now that's a surprise. Oh, it's a 1 here. There we go. So I expect this to be unity, or the identity matrix. And it is. So we just need to check B, C, B, which should then be C to minus first. If it's the cyclic, it should be C itself. or just say that having done this, the others must give the same. But now let's do it this way. If I'd been doing this a lot of times, I would know whether multiplying from the right by this would exchange rows or columns. So I'll just check it here. 1, and that gives that guy. So that gives the first column here is that column and that column. So it changes columns. And then the other one here it changes rows. And this was c squared. So that gives us the identity of the symmetric group of order 6, S3. So that was the positive identification. So let's go to the y squared equals x to the third minus nx n not a perfect square. So the points of order 2 are so K2 equals the rational numbers extended by square root n, and we have 1. So it's of order 2, so we only have 2 elements in the Galois group. The identity, and then the change of sign. Let's call it C for conjugation, giving us the conjugated element. And that's obviously an exchange because naught doesn't change. So that must be one of the exchanges. So let's just choose B for that one. Now, what was I going to do? Describe the image. So it may be the exchange, but it may be anyone exchanging. So any exchange. So they must be C, B, C minus first, or C minus first, B, C. That must be the 3. Or so that's the possible maps. One of these. right, that was A. Now B. The points of order 2 are, oops, so K2 equals Q itself, so the Galois group is trivial, so the image is the unit matrix. X to the third minus n, and n is not a perfect cube. So the points of order 2 are third root of n, omega, third root of n, and omega bar or omega squared, let's say omega squared. Point 0. Now why do we do it like that? The points of order 2, point naught, where t to the third equals n and omega is the usual third root of unity. And here we have the full symmetric group, I think. So we have conjugation that lets t stand and changes the imaginary component. And then we have the cyclic one, conjugation, and S for cyclic. Doesn't make sense, does it? So that's the full Galois group. Of course, K2 is of order of degree 6 over the rational numbers, so the Galois group have to contain all 6 elements. And that means that that the map onto DL2.2 is onto. So the image is equal to GL2.2 itself. And the last one, this should be it. It's a symmetric a homogeneous polynomial, so it must be the product of two homogeneous polynomials. Yeah, that's right, minus n to the third. Good. So the root here x divided by n, to divide by n, then y squared plus y plus u1 equals nothing. So this is omega. So x, now the root is, I shouldn't call it x, wasn't this somewhat like what we had the first time? That, I don't know, q, no it's not, q must be extended by the third root of unity. Nope, we haven't had that. So it's order 2 over the rational numbers. So it contains of the identity and then complex conjugation. Or the conjugation, which is the complex conjugation. And we had that already. That was A once again. So I claim that the image is the same as in problem in part A. So, Saturday morning, problem 6 solved.